Hello friends. I am Satish Lele. This video is part of my chemical process piping channel on YouTube. This video is about piping layout. Preparation of piping plan drawing. The general plot plan drawing shall give the layout of the whole plant S. It should be prepared in accordance with one of the following scales: 1:500, 1:1000, 1:2000. The following items shall be shown in plot plan drawing. Battery limits of complex area boundary. Plant geographical and conventional north. Elevation. With regard to the nominal plant 0 elevation. Coordinates of main roads, process units, utility units, buildings, storage tanks and main pipe rack. Location of flares and burn pit. Direction of prevailing wind. Plant coordinates may be started from point M equals 0 and E equals 0. Layout in process units. In cases where process fluid is run by gravity head, elevated layouts must be considered, unless there are any such limitations as indoor arrangement and confined locations. Equipment shall be placed at grade as a rule, except in cases where gravity flow is specifically required for any reason. Since the directions of the incoming feedstocks, outgoing products, and utility supply are determined on the overall plot plan, first the direction of the pipe rack in the unit shall be decided. Equipment shall be arranged to minimize piping runs, particularly for large-sized piping and alloy piping as far as possible. Clear access ways having minimum width of 600 mm shall be provided for the operator's access around the equipment. Large capacity storage tanks containing flammable and explosive fluids shall be located in outer areas as far as possible. Space shall be allowed for the provision of future spare equipment. Consideration shall also be given to future plant expansion. The drawing shall show the following items: conventional north, coordinates of battery limits and routes, symbols for equipment and coordinates of their center lines, finished floor elevation, equipment index list. The drawing shall be prepared in one of the following scales: 1:1500, 1:1200. The area of any unit shall not exceed 20,000 square meters, and the length of each side should not exceed 200 meters. For units processing flammable fluids, the central control building shall be adjacent to a road. It shall not be located in any area classified as Zone 0 to 1. Process requirements. Equipment shall be laid out along the flows on the process flow diagram, especially the fractionators and the reboiler, condensers and overhead receivers shall be collectively located. Gravity flow lines shall be laid out with consideration given to related elevations, so that their lengths will become minimum, especially in the case of lines in which liquids will flow near at their boiling points. Related equipment shall be located close to each other so that the lines need not be elevated. Pieces of equipment which are to be connected by large-size piping or alloy piping shall be located close to each other. The coolers shall be laid out so that no heated air may be recirculated. Safety requirements. All process equipment should be kept at least 15 meters from fire heaters. Exceptions are permitted for certain pieces of equipment where the heater in question is being used to heat the process flow of the equipment and where any leakage from the equipment would probably ignite instantly, thus no additional fire hazard. Such an exception is permitted when locating reactors on a reforming unit. An example. Each exception must be individually investigated as to its potential hazards and must not violate any process practices in OGV plants and governing codes. Locate fire heater on the side side of the process unit from which a prevailing line blows. This is done to blow gas away from the heater instead of towards them. Fire equipment shall not be located in hazardous area classification. Generally, fire equipment shall be located at a distance of more than 50 meters from any sources of hazards, hot oil pumps, light end pumps, compressors, etc. Emergency showers, if required in a certain process, should be located as near the hazard as possible and indicated in the plot plan. Adequate and easy access and egress must be considered for not only safety, but operation and maintenance requirements. Control rooms and their roadways shall not be located in hazardous area, classified in project specification. Generally, they shall be located at a distance of more than 50 meters from the nearest equipment. High-pressure gas compressors shall be located at leeward locations. Large capacity hazardous material storage tanks shall be located in outer areas as far as possible. Pumps intended to handle flammable materials which fall under the control of the hazardous area classification shall be located on the following basis. Fire heater stacks shall be located at such points that the performance of the air coolers and operators on tower tops may not be adversely affected by hot flue gas emitted through them. The directions of prevailing line shall be taken into consideration in the determination of the stack locations. Inside battery limit. This is piping inside process plant. Generally each floor is per meter high. Pipes should enter in the plant at 2 meters above floor level, at one or preferably at more locations. The pipes are laid along the wall or structural columns. This helps in supporting the pipelines. There can be 1 or 2 layers of pipe lines inside the plant. The distance between two rows is such that branching above lower layer and below upper layer is possible. The branching distance depends on size of the pipe and length of the elbow. Steam pipe is placed near the wall. Pipes of higher diameter are then placed near the wall. Other pipes are placed as per gap table. The pipes may move one layer to other while change in direction. Piping of vapor lines, when it originates from top of reaction vessel, it rises up and connects to a condenser. There should be a number of vents as possible, which allow the pipe to expand while heating or contract while cooling. The line should have a slope towards reaction vessel, so as to drain all liquid to reaction vessel when reactor is closed down. The pipe line should not obstruct the agitator assembly on the top of the vessel. When it originates from top of distillation column, a loop is created at the top outlet of the column and then the line drops down. At lower end, 2 or 3 vents are provided before it enters into condenser. Such flexibility is not required for pipelines at ambient temperature. How to create a piping layout drawing. To create a drawing, first put in drawing plan the locations of columns at proper distance. Mark the columns in both the direction. Put beams of proper width. Cross-mark the areas where no equipment are placed. Place the equipment in proper location, showing all nozzles. Typical details of one equipment. Utility lines are put in central bay which supply utilities to the equipments. Interconnecting piping is then drawn for each vessel. Proper gap is maintained between pipelines. Typical piping details of earlier equipment, which shows connection and steam control station. Line numbers and elevation of each pipeline from floor level are marked on each Pipe lines arranged in such a way that a number of lines are at one elevation in one direction. In other direction, the pipe lines are placed 300 to 500 millimeters above or below the earlier level. Outside battery limit. This is piping outside process plant, in storage and utility area. Some pipe lines carry raw materials to the process plant. Finished products are transported back to tank farm area from process plant area by other pipelines. On grade, this is generally around the storage tanks. Grade is made of a brick wall 300 millimeters high or a steel structure. If it is a wall, the steel rod is embedded on top of it. The pipes rest on the steel rod on wall. The distance between the two grade walls or structures is decided by smallest pipe running on it. The distance between two pipes is decided by the spacing table. On pipe racks, when the pipes cross a number of roads, it is put on the pipe rack. The pipe rack is generally at such a height that a truck carrying container can pass under it. Here, the distance between two pipes is decided by the spacing table. Method of placement of pipes on grade or pipe rack. The storage tanks normally have guide wall around it. The pump suction piping is routed over the wall. The piping for the last tank is put in first. The pump suction line has a block valve on tank. It has a strainer near the pump. It then connects to the pump suction through an optional block valve and an eccentric reducer. The distance between wall and pump suction should be at least 1 meter to accommodate these fittings. The discharge line of pump has block valve, followed by a check valve. A pressure indicator is located before the block valve. The horizontal pipe from pump should not be located over the pump or motor. The pipe line is then placed on grade. Sufficient vacant space should be maintained for maintenance of the pump. The piping for subsequent tanks is placed in order. The gap between pipes is fixed as per gap table based on pipe diameter and class. If another pipe is to be placed in between, all pipes are moved as per the gap required. The sequence of the pipes can be changed when there is a change in direction. The steam pipes should be placed at one end. To create the piping plan, place the equipment in proper location, showing all nozzles. Show diagrams around the tanks. Pipe lines are put on grade which supply utilities to different equipments. Interconnecting piping is then drawn for each vessel. Proper gap is maintained between pipe lines. Line numbers and elevation of each pipe line from floor level are marked on each line. Pipe lines arranged in such a way that they not cross each other. Typical details of two equipment. Dimensions of pipe gap. Thanks for learning. If you like this video, please give a like to my channel and